So I work for King, and we make, can anyone remember which games we make? Those ones. We make casual, social games that delight hundreds of millions of players around the world. Actually, can I have a quick show of hands? Anyone who's played one of these? These are our sort of 8 of our most popular titles. Wow, that's actually really impressive. OK, hands down if that was Candy Crush. No hands left. Oh, no, good. There's a couple of my colleagues there who've played some of our other titles. But hopefully, since a lot of you have played those games, thank you. And hopefully you've seen just the tons of love, creativity, and hard work that's gone into creating those experiences. And today, I'm going to show you a bit about how also there's a lot of science and a ton of data behind making sure they're enduring successes. We've actually been making games a long time, 15 years now. King's been going, making over 200 mostly less successful games. Well, so last year in particular was a really big success for us. We actually hit record revenues across mobile platforms, and our top 2 titles, that's Candy Crush Saga and Candy Crush Saga, we're back at #1 and #2 in the app stores for top grossing games in the US. That's something that we're really proud of. It really makes it a really fantastic, unique experience to be part of the story of that. And certainly part of why last year was so great is that there was a lot of fanfare, a lot of celebration, a lot of PR around Candy Crush Saga, the original, hitting its 5th birthday. But part of what made it, I suppose, successful in the first place was that 5 years ago, the world of gaming was rather different. So when I grew up playing games, there were, you'd go and buy what was a fairly finite lifetime product. It had a bit of story. Maybe a bit later on, there'd be additional content that was released that you might enjoy playing. But basically, it wouldn't last very long. And among other things, Candy Crush's design was such that it's one of the early games on mobile where we'd keep updating it week after week with new content, new levels to play, new features. It was a bit more like a game as a service, like people had been learning how to do with web analytics for the decade before that. And that constant cadence of releasing new stuff, as well as providing lots of challenges that I'm going to talk about some of, also provides tons of opportunities to learn from the data that are generated and keep feeding that forward into the design process. And so I'm going to talk about how that works. But because this is a sort of a general celebration of all things data science today, I find games a particularly fun way to apply data science. But I want to talk a bit about generalities, and I hope that whatever area of the world you work in, you'll find something useful to take away from what I'm talking about. So I want to reflect a little bit about how data works well in general. And there's actually been quite a few really good talks throughout the day about things to do right, to avoid as part of that practice. Probably many of you are familiar with this. It's the typical life cycle of a data science project where we try and transform data and ideas of what you might do from it into actions and essentially impact on our businesses. And I'm going to show a few examples of how each of these areas works at King. But I want to start with more generality and reflect not perhaps on the rise of sentient AI that might take us over all, as we heard about in the talk before this one, which was quite fun, but really about how data science, from my perspective, as you just heard, my background is physics. I was a scientist to start with. The rise of data science is part of the history of science. And for me, the history of science is the history of measurement. There's actually one picture missing here. I don't know if it's going to show up. No. Well, anyway. But here I wanted to show a few of the landmark developments of technology that have enabled us to measure more and more detail, to monitor and understand the world around us. Starting from Hooke's, one of his early microscopes that allowed us to see what cells were up to. Moving to Harrison's H4 watch, which allowed precise measurements of longitude and the circumnavigation of the globe. to X-ray crystallography, the first measurement of the structure of our DNA. The eagle-eyed among you, or pedantic among you, that is, of course, not a measuring device, it's a measurement, but I think a very important one in the history of human discovery. And then top right there is a weather radar, which spun out of military applications during the wars to try and identify enemy planes, but has now turned into a really rather positive thing to help us decide whether or not we should take an umbrella to the park. And I was going to show on the bottom right there something which has really sort of springboarded data and our understanding of the world to a new level, which is the Large Hadron Collider at CERN, which is also close to my heart as a physicist. And of course, the technology developed there before Large Hadron Collider for the LEP gave birth to the internet as we know it today. And the challenges of learning how to understand and process the huge volumes of data generated from those experiments are part of the story of why we have such a connected world that we can learn from in whatever businesses I think many of us here today are working in at the moment. So I guess the first message I wanted to leave, and the reason why I thought this is important, is because actually, in order to have impact in our businesses, making sure you can measure stuff is probably the most important thing you can do. And often it's not about developing really clever, insightful algorithms or productionizing stuff. It's about identifying and collecting relevant data and then feeding that into probably fairly simple business decisions. And I'm going to start off then with a bit of example of what that means for us here at King. So what sort of data do we collect? Well, actually, a ridiculous amount of it. So wherever you are in the world when you play our games, if you're online, that'll send back a feed to our servers in Stockholm. And really, the vast majority of what we collect is the detail of how you're finding the experience of playing that game. So over on the right there, for those of you who haven't played Candy Crush, this is what a level in Candy Crush looks like. It's a finite-sized board, and you have different coloured candies. You swipe to match them, and when you match them next to each other, they vanish. You get points, and it helps you achieve other goals. And if you achieve all the goals within a certain number of swipes, then you pass a level and you get a new level to play. And if you don't do that, you have to keep going. And this particular level I'm showing here is a level which someone in the USA played, and that turned out to be the trillionth time someone had ever played a level in Candy Crush. So quite a milestone for us. And the sort of stuff we know about it is what device was used, the precise time, and we know the kind of detail of what the experience was of that attempt at this level, so how many points were scored, whether it was a success or a failure. And surfacing this data is just a really simple thing for many people in our business. Perhaps it doesn't quite count as data science as we might know it, but it's really useful. So the designers, our teams of designers who put all this content out there all the time, they want to know how the players are experiencing that content. They want to know that the designs of their levels are kind of, once people start playing them, meeting their expectations. And so a really simple thing that you can do and allow the designers to see is how difficult the content is. And this chart shows for a set of 15 levels in Candy Crush just how hard people played them over some time period. What do I mean by hard? Well, success rate on the y-axis there is a simple count of the total number of times during that time period people won that level, divided by the total number of times people attempted that level in that time period. And the reason I wanted to show this set of 15 levels and this range of difficulties is actually because if you find any of this stuff interesting, you can play with it yourself. We've got some data public in DataCamp, which is a really awesome online platform for learning data science. So my colleague Javier in Barcelona worked with them to put this together. And it takes you from producing a chart like this where you look at the difficulty and you put what here are shown as simple binomial confidence intervals to let our designers theoretically know if this is new content and only a few people have played it, they probably shouldn't read too much into exactly how difficult it was found yet. And I guess one of the things that I'm going to come back to time and time again is that actually behind these simple numbers, actually there's a ton of detail, and data science comes in to help us dig deeper, help the people who are making use of this information understand how to best use it in decision making. So let's say a designer is looking at level 5 here and thinking, that's kind of harder than I really wanted that to be in this flow of 15 levels that player might be exposed to. So I want to maybe look at that in a little bit more detail. So time series are often very useful ways of looking at our data. Time series can reveal trends, which might tell us something about how the audience is changing over time. Particularly if, as a designer, I've made a change to a level, or made a change to, let's say, how many moves we allow players to have to take that level, then I want to see if there's some sort of step change in how difficult people are finding that over time, if that's meeting my expectations or not. And of course, if I make other changes to the game, those can sometimes have unintended consequences. Stuff breaks all the time when we're releasing stuff as fast and frequently as we do. And so monitoring time series for weird stuff that's unexpected is also pretty important. Here there's nothing super interesting going on, I wouldn't say, in the time series, except that given that I've plotted those binomial confidence bounds on each difficulty point by date, there's maybe a little bit more variability than I would expect. I think if you do go and play with this data set, there's quite a few thousand people in each point here. So the central limit theorem should probably be meaning I'm close to the binomial bounds. But one suggestion I have for anyone who's working with relatively small sample sizes is that over-dispersion can often be better explained by models such as beta binomial models. I don't know if anyone's worked with those. Maybe, but what they do is say that rather than the assumptions of the binomial, that all players have a fixed probability to pass this piece of content every time they play it, they say, no, actually, there's a distribution over players. Not all players have the same expected probability to pass every time. And that model then might hint at how we might want to think about, with our designers, understanding and adapting our content to cater for it. And there's some interesting results that another colleague of mine produced and talked about it at a nuclear AI conference a few years ago, which validates that hypothesis that actually distribution over players of skills might be an important thing for us to consider. So this shows that for players who we will generate a skill score for by some method that I'm happy to talk about later if you're interested in the details. But if we identify players who are consistently good at passing levels, then we might find for a typical level that they seem to pass it way more frequently than a group of players at the bottom here who have consistently in the past struggled with content, and on this level seem to be having a really, really hard time. And so the message here really is that behind simple averages and behind what for us is actually generally a really great problem to have loads of data, if you don't dig in, if you don't understand that some players are experiencing things differently, you might miss a segment of players who you might really want to cater for and work out how to help out for some way. So hopefully I've given you a bit of an idea, at least for one group of people in our business, of the ways that data start to help them get good feedback on what they're doing and thinking about how to improve levels. And the fact is that when you have a game like Candy Crush with over 3,000 levels, that's just a really hard task. Our level designers can't possibly cope up with, keep up with all the monitoring, all the kind of checks that they might want to do. So we have a team in Stockholm who've been working on AI systems that play our games. They've tried lots of different methodologies. What I wanted to show here is just one result of that work, which was talked about by my colleague Alexander Andelkovic at TestCon last year. And what they're doing is trying to make sure that before we ever release levels to the public, the designers already have a really good idea of how hard that content's going to be. That's really important because if you release content that's way too hard or way too easy, you either really annoy players or you really disappoint them, and also make it that it's likely that we might lose revenues as a company. And what we used to do in the past was pay an external company to find a group of people who are happy to play and test these levels out for us. And we'd get a relatively small amount of data back from them about how they found the experience. And that was OK. It was slow, it was costly, and that's what's shown on the bottom of these two charts. It's showing the distribution from giving the game to a small group of people to test out, of how far from the real difficulty we saw when we finally released that content their estimates were. And on the top, which is way better, way cheaper, and way faster, is what our current best AI systems can do. And I guess it's worth saying, you might have seen videos of AI playing computer games like Mario out there. They get really good at playing Mario. We don't want AI that's really good at playing Candy Crush. That's not quite what we're looking for. We're looking for AI that plays how our players do, because we want to understand the players, we want to be able to simulate that. And in terms of getting the difficulty right, which is one of the basic things our designers care about, they do that really well. But we can also do more with them. So given that they're playing like real players do, we can help our designers out with tons of other really interesting information and statistics that come out from those bots playing those levels. For example, how many different choices do a player have on average, which can correlate with how fun that level might be? Or how powerful are the different in-game boosters in different situations, because the bots can learn to use those in the ways that players do as well. And one other use, which this chart illustrates, although it's actually, this chart is generated by a different algorithm which learns directly from data. But the principle is that if you have a bot that can play your levels like the real players do, then you can also give it different designs. There are generally quite a few parameters that describe what a level is designed by a designer. For example, in this case, I'm considering how many moves the players are allowed, how many swipes they're allowed to make before they have to try again. But it might all be the number of different candies, different colours that are on the board. It might be the amount of different jelly you have to clear, or the points target you have to get, for example. And then, rather than having to manually go through the process of make those changes, get people to play them, get feedback very slowly, we can just feed that to our bots and say, hey, you know, if you, as shown on the y-axis here, if you remove one move from how many moves you give the players, that's going to make this level that little bit easier, and so on. And then the designers can make some decision about what they think is the right difficulty for this content they've designed and push it out there. And so hopefully, you know, that's giving you a bit of an idea of how automation and AI really help make the business much more efficient and have a much better idea of what we're doing before we expose players to it. But what I haven't talked about in these examples is whether it really matters in terms of the long-term future of the business. Just because a designer has some idea of what they think a great experience or a great fun level might be, that doesn't necessarily mean the players agree with that. You probably saw with those that graph of level difficulty, sort of generally the difficulties hover between about 50 and 10%. Is that right? Do players find that level of challenge appropriate? You know, the answer is we don't really know unless we run tests. I think we've had quite a few people emphasizing the importance of experimentation throughout the day. I'm certainly not going to disagree with that. I'm also not going to talk about it at length. But I do just want to reiterate a few of the basic points that A/B testing is really important to help us just understand that, the long-term impact for the business of the changes we make. It's really important to build trust around the business. So I think before we had a really good experimentation platform, there was an awful lot of people just saying, no, we want to do this, we believe in it, we're going to move on, and a lot of opinions that are now backed up with evidence that we have a good A/B testing platform. But actually the most I've found over the 5 years I've been at King, the most really interesting transformation that a really good centralized A/B testing system has brought us is a really good sense of risk-taking. So as well as trust problems in the past, actually, we were pretty risk-averse. We were a pretty cautious business. People would maybe tweak a level and want to see what would happen. And the fact is that that's never really going to transform the business and take us to the next level. But over time, as we build out a framework which has made it easy to test stuff, as we kind of found ways for the business to hedge the risks of trying out more interesting, novel ideas. For example, rather than testing stuff in Candy Crush, testing stuff in one of our less successful games, or just testing stuff in a relatively small country. Then seeing some successes, certainly seeing quite a lot of failures, because failing fast, learning is really part of the game. But seeing some big successes, seeing that whatever ideas people had could lead to big differences, double-digit improvements in important business KPIs. People kind of get hooked on that stuff. And you see more and more of that happening. And that's where I think it's very safe to say a lot of the success and renewed growth of Candy Crush last year has come from a really good unified approach to getting an excellent stream of well-validated experimental results learnt from around the business, those best ideas into our top product. So think about how you might be able to replicate that in your business, if it's possible. And so I don't want to talk too much about A/B testing, but I do want to show just one bit of data from an A/B test. This one's actually not from Candy Crush, but it is about a hypothesis that some designers had about how improving that core level design might improve the player experience. The reason I wanted to show you this is because it's taken from a centralized A/B test analysis tool, and that's actually also been a really important thing. So we now have close to, well, I think we've got about 80 data scientists spread around the business. And again, in the past, there were issues with trust because everyone kind of did stuff their own way. They're all very well intended. They're all good scientific people who documented how they did it. The code was always available, but it's pretty slow to go and try and work with that and understand what they've done and try and see what you can understand from it to realize if that's going to be something good to do in your part of the business. So we've invested quite a lot in centralizing the metrics you look at, in centralizing the UI, which produces charts which look a bit like this, which is maybe quite simple, but you can see there are annotations available. For example, this just has the start and end of the test, which have been automatically populated, but we also have annotations which show you if there are important things like client releases in that time. It shows you if there have been any serious incidents, so problems with the game in that time, and or limited time events that might be relevant to helping you interpret the results. So it's a great exploration tool, and if everyone uses that same tool, they can then go off and do their own analysis, throw their own methodologies, and report back on what they learn like that. But we've got a solid core of trust that's been built through centralized tech. Just to actually clarify what this is showing, it's between test and control group, where the test group experienced slightly different levels according to our designer's hypothesis. This is the ratio between test and control of the total number of attempts at levels in each group. So it's a metric which captures for each date how many attempts were made by test, how many attempts were made by control, and that's a sort of captures just how much time people are spending in our game, and that's something we really care about at the business. And we don't just care about whether immediately after we make a change people are spending more time in our game. In fact, pretty much all the big changes we make lead to some sort of novelty, some sort of short-term dynamics which tends to wear off over time. We care about the long term. And so it's important to view time series to understand if there are novelty there. I wouldn't say that given the high variability in this chart, that's necessarily what's happening here, but it's important to bear in mind. Generally what we're looking at, generally the decisions we're trying to make as a business are based on some long-term stationary regime. And there's interesting statistics and important stuff to think about how to do that. And again, having one centralized place where everyone's research into the good or bad ways to do that can go and be well engineered into a nice product is really valuable. I do want to emphasize again the confidence bounds that are plotted on this. These are just the point-wise estimates of the variance of each individual measurement, not so you're going to have to do some aggregation to try and understand the long term and come up with a good confidence interval for the mean. And because I care about statistics, I want to make, I guess 2 points. One is just that probably this experiment, and quite often experiments we run, end up with no what we might call classically statistically significant difference from the control group. And I get quite annoyed when people just say, yeah, this experiment didn't do anything. Reporting the confidence bounds gives us way more information. So particularly if I'm running an experiment with maybe a small number of players or in a small game, and there's quite a lot of variance, there's a massive difference between being able to say, well, I'm 0 plus or minus 5%, I'm 0 plus or minus 1%. If Candy Crush can take an idea which has at least some potential and turn that into 1% extra profits over the year, it's a lot of money and it's not worth discarding straight away. Although we probably want to look for more evidence, run more experiments to back the idea up before we go ahead with it full steam. The second point I want to make is just well, actually a similar one, that, yeah, where the business is going based on what you predict as the outcome of your experiments. It really doesn't only care about the average. And rather than what that might mean for Candy Crush, I think it's better illustrated by this, which I really like from Nate Silver, writing about Hurricane Irma, which happened in September last year. It's a bit difficult to interpret this chart at a first look, so go and read his post because it's a really good story. But what this is about, it's about how the meteorologists made probabilistic forecasts of where the hurricane might strike the coast of Florida, and how day by day those forecasts changed and gave different ideas to the public and to of course the emergency agencies who want to prepare for any potential damage that's coming from this. And actually the meteorologists did a really great job. And so by the time we got really close to Florida, that cone of uncertainty captured exactly where the damage really did happen. But what's really sad to see is when the press pick up on these nice forecasts and come up with a message like this from the Associated Press. So, breaking: Hurricane Irma center shift west to gain more strength and aims for St. Petersburg, not Tampa. St. Petersburg and Tampa, they're like there and there or something. And they're both completely covered by that cone of uncertainty, and it's actually very irresponsible of the press to sort of give the wrong impression to the citizens of Tampa that they're kind of in the clear now. Fortunately, the hurricane actually missed both of those completely and actually got further east than them, which was well within the probabilistic forecast as well. The analogy, and the reason I'm making this analogy is that if when we find A/B test results and we just tell the business, on average this is where we're going, we're being irresponsible, and we're not helping people understand the full potential range of outcomes that we might want to worry about. And I'm going to stick with meteorology as an analogy. That's why I put the weather radar up earlier, and you heard I actually used to work on flood forecasting systems for the UK, so it's something that's dear to my heart. And I'm British, and we care about the weather, right? But this is actually from the American Weather Agency again, and I want to talk about prediction and forecasting in more general, because beyond my earlier point that data science is really all about simple measurements and data, I think the other core of what data science means is prediction. Whatever we do, we're trying to understand the world around us, and the only way I can make sense of that word understanding is by saying I can make predictions based on my knowledge that are validated with data. So the A/B testing that I just talked about, that's really about prediction. It's either predicting, as with the hurricane, where the business is going to end up if we continue with one particular group, or it's about predicting the parameters of a population from the sample which you have. This chart is about predicting rainfall. What I want to emphasize is that the way you might build a model to predict something, and certainly the decisions you might take based on that model, really depend on how far in advance you're going to make those predictions. So what the x-axis here is saying how far in advance am I trying to predict whether it's going to rain or not. On the y-axis, it's showing the accuracy of your model. And I guess another important point here, so the model is the blue bars. And it's always really important when you build a model to perform it, to compare it to something, either your current best model or, in the case here, of some really simple assumption. So a really easy way to predict rainfall is just saying, is it raining today? If so, it's probably going to be likely to continue raining. And that certainly holds in Britain. But of course, that's not very accurate. And actually, that assumption gets more and more accurate the closer to the point in time that you're trying to predict. But here, the weather forecasting models, do have significantly better skill than just saying, hey, I think it's going to keep raining if it's raining. And what I want to say is that if you look at a forecast for the weather next weekend, so 7 days in ahead, you might think, well, maybe next week it says it's going to rain, so maybe I'll book tickets to go to the theatre or the museum or something like that. Great. And then, of course, when you get nearer to the time the day before, you suddenly go, hey, now the forecast, which I think is probably more accurate, says it's actually going to be super sunny. You might think, well, that's a shame. Maybe I'll go to the park instead if I didn't pay too much for my tickets. I don't know. In either case, the forecast might not be accurate, of course, and you might go to the park and then get rained on. It's rather sad. Yeah, if you know the day before that it's actually really likely to change, maybe you'll take an umbrella with you. But there's different sorts of actions you're going to take depending on when you hear that forecast, different ways it's going to affect your life. Particularly, I want to analogize with one of the most common predictions I think people talk about when applying prediction to businesses, which is predicting churn, predicting whether your audience, your players in our case, are going to quit and stop playing. And certainly you want to understand and take different actions as a business depending on how early you can predict that potential event. And perhaps what we see too often is people who predict churn after the event. And predicting churn after the event is a bit like predicting rainfall after you got soaked last weekend. It's not really, you can't really do much about it. That doesn't mean it's completely useless. You can still understand what it was that would have been predictive about that and work out how I might think about doing things in the future. But it's not nearly as useful as trying to say, well, why do I care about predicting rainfall, or in our case, churn? What might I as a business do about it? So actually, who here did anyone come to our meetup that we hosted on Thursday? I think I can see a few of you here. Thanks, it was really fun. And my colleague Georgie talked a bit about this sort of stuff in more detail then. So check out the slides and videos from that if you're keen to hear his thoughts on how to get prediction problems set up right in a business. But it's the second point beyond timeliness is to make sure that you tie what you're trying to do into what the business might do about the predictions you're making. So just a sort of simple example on the left here. If you're thinking, well, people who churn might have that sort of decision, or might have the reason why that's happened swayed if they had some more fun in-game boosts or some currency which would help them get out of a really difficult situation where maybe they've just been really unlucky and stuck on a level for a long time. And so the features you're going to put into that algorithm and the tech that you're going to need to set up in order for our games to be able to react in real time and deliver that service to players are completely different to what you might do over on the right, which is what I talked about, the sort of, well, we know a lot of people have stopped playing our games already. Let's try and reverse engineer why that was, and let's think about how we might improve the game so in the long run, less of that happens. But we can't do anything about those people who've already gone. That's a missed opportunity. And yeah, one more thing I want to say about prediction and churn prediction is that there's already been so much we've had to think about, right? So we've got to make sure we get it in a timely fashion. We've got to make sure that there's some actions we're going to take on it. And again, that's still all useless if those actions are really ineffective. So one of the examples from the last slide was sending emails to people who churned years ago. That doesn't really do very much. So how do we tell whether the actions we're building on top of our churn prediction are going to be useful? We A/B test everything, right? So A/B testing every time. And the funny thing is, when you start building A/B testing on top of your churn prediction, you actually stop doing churn prediction. So again, take that example I just made of gifting, let's say, hard currency to help you out in our game to people who we think are about to churn. Probably the best way to learn whether that's effective or not is just to do that for maybe all players, or maybe what we think are a safe group of players to do it based on some churn prediction algorithm. But we do that, we run an experiment, see what happens when we give all players some gold bars, and then we learn. We build a predictive model that says, which takes whatever features we think might be important into making the prediction, but it predicts what the uplift in that experiment was. So we're not predicting who's going to churn and then deciding what to do. We're saying, given that we're going to take this action as a business, let's predict who that's going to be effective for. Maybe it's not people who are likely to churn. Maybe it's just people who need it for some other reason. But that idea of actually bypassing churn prediction and making it all about churn prevention or whatever other metric you want to improve for a business is way more important. So I've got a few minutes left, and I've talked mostly about setting up business problems and a little bit of statistical flavor. It would be wrong of me not to talk about tech a little bit. As a scientist, I've been biased, I think, but I recognize that it's extremely important to have good engineers and good data engineers, but also great data scientists with a computer science background working with us. Because trying to apply these simple concepts at scale, trying to make them run fast, trying to make them robust is not easy at all. So here's a representation of that 40 billion events that we get in every day that come flowing into our data stream, trying to do simple things like say, hey, I know this player experienced some kind of problem. A developer might come to me and say, can you help me find the rest of that player's data? How do I do that? It's not straightforward when you've got data stored in HDFS, for example. Basically, if you want to read your entire database and filter on one user ID, that's not fast. So trying to recreate histories or try and understand problems is very challenging at scale. And so actually we've got some services which help with that, which I guess maybe I can talk to anyone if they're interested afterwards, but I'll just press on and show you a bit about our tech stack, which probably looks fairly familiar to a lot of you. We have a lot of batch processing stuff still. I mentioned using Hadoop, HDFS for file storage. And we, of course, have Hive and Impala, which sit on that. We do a lot of batch processing, all those systems which help our level designers, for example. Generally, that's stuff which is aggregated and processed and served overnight. Generally, if we're training models, it's based on these systems. We actually have the world's largest exasol classer. That's a super fast in-memory database. It's a lot of fun to work on a computer with a terabyte of RAM in it. One thing for this year, which we're all excited about, is we're starting to migrate services to use Google's cloud analytics. So watch this space for more of that. And we're excited to see what we can do with their scaling capacity. But the last thing I want to talk about before we can all go to coffee is something I think which is super fun, and that's a move to more and more real-time analytics, real-time data processing. So we've chosen at King to build that on Apache Flink. We have a tech blog which has some details if you're interested in this stuff about what we're doing in this field. One of our products is called RBayer, which is a rule-based event aggregator, which allows some fairly helpful but what seem straightforward at first glance tools, but it's actually a super cool system I'm going to show you one example from. So this is something that actually another colleague, Lukasz Korbolowski, talked about at the recent Game Developers Conference this year. And it's in partnership with a company called Anadot. And they ingest our real-time data streams and with a whole suite of algorithms help us identify anomalies. We also have in-house products that do this, but this looks nicer. They've engineered the front end really well. And what you can see here is actually for one of Candy Crush running on one platform over a day. It's again game ends, it's called here, but that's still that count in 5-minute buckets of just how many times people are playing levels. And this system has, by learning from past data and us helping flag what we care about, some anomalous regions, the blue region and the orange region. And the orange region was actually a really serious incident where Candy Crush became unplayable. And if Candy Crush is unplayable, we get rather worried. Fortunately, this was in the late afternoon, not at 3 a.m. in the morning when we have to panic and call our engineers out. But it's really important that when something like this happens, we detect it super quickly, get on it and fix it. And these AI systems have really helped both improve the accuracy of understanding what is an anomaly and also the timeliness that we can do that, and also reduction of false positives, because it's a really big problem. And just to give you a quick sense of the scale of that, we have 40 billion events coming in every day. We can, with some business logic, combine similar events together. We use that rule-based event aggregator to generate about 20,000 time series of 5-minute bucketed important things which we might want to monitor. That all gets fed into this suite of machine learning algorithms that spit out what look like anomalies, and we still need a team of people who have the kind of product sense to understand, well, which ones out of those are really relevant, which ones might we have to wake up our engineers for. And just to illustrate the benefit to the business, no scale here, but we've increased decreased the time to detect those severe problems 20-fold over the last 2 years. And when you convert that into time when Candy Crush wasn't offline, it's not hard to see that AI has helped steer the business in the right direction. And that's where I'll leave you with just a sort of summary of the points that I think I've been making. So, measure everything, A/B test everything, automate where you can, make sure you engineer it well and robustly so it scales up, and be great evangelists for data in your company. Thank you very much.
Okay, we have time for a few questions, I think.
It's a bit hot.
Yeah, I think everybody wants to go out and cool out, chill out. We got a coffee break.